Hi, welcome to the final installment of our three-part series, AI 101. In the previous two sessions, we discussed an introduction to large language models and enterprise generative AI, as well as the risks inherent with using this technology in an enterprise setting. Now we'll be building on these concepts to discuss how to craft your Copilot strategy. With us, I have Matt Mistoli, ML Engineering Manager here at Moveworks. We'll be discussing the strengths and limitations of the 4 tiers of enterprise copilots and how to use this knowledge to craft your Copilot strategy. If you have any questions, please ask using the Q&A module located at the bottom of your screen. Now I'll hand you over to Matt for today's session. Matt?
All right, cool. Thank you so much, Will. So there has been, in the past 5 years, actually 5 or 6 years, a Cambrian explosion of large language models. Starting from just simple representations of words as similar words get put close to each other in space so we can work on them the same way, to then a tree of representing entire sentences or documents as close together and able to be treated similarly on this kind of this encoder type of large language model. And then we have on the right hand side, we've got decoders that are able to take this information and output text and kind of do all the kinds of things we've come to learn know and love with ChatGPT and other large language models for generating text, and some models that do kind of both in the middle. And there's almost been a bit of an arms race in creating bigger, better models by lots of different companies, as well as open source communities. For example, we can see on the bottom right here, we've got these lots of different companies that work in AI, both releasing open source models, which are the kind of ones with the solid color, and as well as some closed source models that they published about and use internally, but haven't made accessible, or have made accessible via an API without letting people know the internals. So in general, though, there's a huge proliferation of large language models for all types of things. This is just like the public one of things that people generally have published about. Also, companies like Moveworks have been doing all kinds of fine tuning on top of these models to make them more specific and better at enterprise use cases. And what I'm excited to talk to you about today is how to think about your Copilot strategy and what you can do, how you can take advantage of this large proliferation without having to worry about all the details of these, this specific model, that specific model, and so on, unless you're going particularly deep, as you'll see. So, here we go. So a Copilot, the enterprise definition of Copilot, rather than kind of flying planes, that we like to use is a conversational interface for automating tasks and finding information that leverages large language models. And these new Copilots are emerging every day, from ChatGPT for, kind of operating with just text to, Einstein GPT with Salesforce, Replit with code, Slack for doing things in Slack, and so on. And it almost feels like truly everyone gets a Copilot for all the things that they want because companies are developing them left and right. But this particular is a relatively new development in terms of tons of companies doing it. But we've been in the business of making Copilots for IT, HR, and other enterprise service for many years. These are just a sample of some of the enterprise Copilots effectively that we've been building with our customers since Moveworks' founding. And, over the many years of building these on all the successive kind of advancements in artificial intelligence and large language models, we have a lot to say about how should you think about your Copilot strategy from all that we have learned. In the next few slides, I'd love to walk you through a framework and a mental model for thinking about the various considerations, the investments, and the expected benefits of different tiers of enterprise Copilots. So, what building on large language models can feel like right now. I don't know if you all have seen this, the kind of how to draw an owl. Step 1, draw some circles. Step 2, draw the rest of the owl. So as considerations like performance, privacy, analytics, and more, it can feel like there's a bit like jumping from drawing circles to drawing an owl. But, if this is how you feel, then don't worry. Because over the next 30 minutes, I want to help you build a framework, like a mental model, if you will, for how to think about harnessing large language models for your use case. So what large language models you want will depend on your use case. One way that we've mapped this out, just like how large language models can map similar types of words and similar sentences to different things in space, We did that with problems in just 2 dimensions of, on the y-axis, we've got the scope of the problem, and on the x-axis, we've got the level of investment with similar types of problems put close to each other on this little graph. And when we can see, there's almost these 4 different tiers of problems and consequently types of approaches that would be needed to have it work, ranging from copywriting for your website and doing sentiment analysis on a sales call, up to more sophisticated things like translating tickets for IT agents with IT-specific terminology in different languages, or answering questions about finance, to summarizing legal documents, where all of these require some domain knowledge. To preview that, tier 3, kind of even more sophisticated things like following up with an account team, multilingual IT and HR support, medical literature analysis, and content moderation. All the way up to on the far side, we have enterprise-wide support, decision-making, and compliance and security monitoring. So it's a lot of text. Let's take a step back and walk through each of the different tiers of Copilot. First one, Tier 1 Copilot, Basic LLM integration. This is one of the easiest and most straightforward to get started with. The idea is you start small in Tier 1 with productivity tools. Things like creative use cases or the single use case analysis. What you need to get started is essentially 2 pieces of technology, or really one main piece of technology, which is large language models as a service. Things like Hugging Face's APIs, Azure's OpenAI service, OpenAI, many other providers, just a few to fit in the slide, where you use simple ML techniques that don't require a whole lot of domain expertise, such as prompt engineering, just writing the instructions carefully to have it do what you want. The investment is relatively minor here. Just pay some API subscription costs for often, at a per request level, often less than a cent if you're using one of the simpler models, or more expensive for using things like GPT-4. And there's some degree of basic developer resources to, for example, do the prompt engineering and just get your system set up to call these APIs. Here's an example of prompt engineering in a talent system. For tracking the applicants and so on, where a user utterance might come in to this tool saying, I need to generate a job listing for hiring a data analyst. And the product prompt might be wrap that, basically automatically take the user utterance and put it in the blank of, you are a highly experienced JD writer. Your goal is to write job descriptions that attract candidates. Be professional and to the point. The instruction for you is to, and then automatically plug in the user text. And then you just take, essentially your code is just that prompt template, and then make a call, take user input, make a call to a pre-trained large language model, such as the ones at OpenAI, and out from the OpenAI, out from your LLM as a service, you get some text, and you show that to the user. Voila. You can imagine other use cases, for example, for basic accounting, or for example, if someone's getting ramped up in sales and wants to know general terminology that these language models as a service might know already. You can imagine you can just change the product prompt, and you can have it be taking knowledge and things out of the language model for your different use cases. However, as if for folks who are familiar with the previous 2 parts of this this webinar series know, prompting will only get you so far, because prompting is an art and can be hit or miss. Slight changes to the template might cause it to fail. It may work on some utterances and inputs and not others. And there are advanced techniques such as auto prompting and prompt tuning that can help. In general, the outcomes may vary with prompting, but it can get you far enough for most Tier 1 types of problems. Though, one thing to keep in mind is that there is a risk of hallucinations, which we talked about in part 2. But here's a little GPT-4 explanation to complement the one I gave last time, which is, why does a large language model like GPT-4 hallucinate? Well, primarily due to limitations in training data. it being optimized for fluency over accuracy, because often annotators are, inputs are coming in that even the annotators that are rating the quality of the outputs don't know the answer to. But they can say, oh, this looks pretty good. So if you're not careful, a large language model may be optimized for fluency over accuracy, or it may not have an built-in understanding of truth or reality. It's generating text based on patterns learned from its training corpus, which is often factual, but these also may contain inaccuracies or inconsistencies, leading to incorrect or unrelated outputs. So in general, if you're just using a large language model by itself, just in comes some text, give the user what comes out, you need to be aware of this and guard against it with things in the coming tiers. So, Tier 1 Copilot summary, basic LLM integration, just an API call with some prompt engineering. And some strengths are, pretty quick deployment. You get access to pretty general AI capabilities without having to spend a long time, training something to do just that. Pretty low upfront cost, and you get some degree of customization. Change the prompt template, get it to do different things out, or with different styles and so on. That said, there are definitely limitations, such as limited domain and organization specificity. It won't know anything about your related to your organization, except things that are public. You maybe have some potential security and privacy worries, where you have to make sure your contract with the LLM as a service is not retaining data. If you want to make sure it's private, and low API costs can become expensive based on usage. And as mentioned before, there are potentials for hallucinations. So you got to make sure that if you're using this, you got to make sure you're very much trusting the company that you're partnering with to use this large language model as a service. And be aware of these things. So what about a tier 2 Copilot? What if you want for a customized LLM implementation? Because some problems, like ticket translation for IT agents, to finance department FAQs about your finance department, legal department summarization, you might need a Copilot that can solve domain-specific problems relating to your documents and related to your specific areas of expertise. And this is pretty hard to do with off-the-shelf models just trained on internet text. So what do you need to get started? Well, there's now a couple technologies you need, starting with a pre-trained model that you can start with. There's a bunch of these, some of which have, to list a couple of them, we got like Llama, Roberta, MPNet, that do different kinds of things, which you can, feel free to ask questions about this more at the end. But a couple dimensions of this to be aware of is when you're picking a model to start from to fine tune on your data, you need to make sure, is it licensed to be able to do that? Like Llama, for example, is only licensed for research use, versus models more open, like permissively licensed open source models like Roberta, MPNet, and Fluenty5 are licensed for you to use commercially. Another thing is, are you trying to have it just output text, or are you having it represent the inputs in a way that then more models can use on top of it? And this is where things like Roberta and MPNet are really great at encoding it to put it in one space, versus models that can decode, like Fluenty5 can generate off of that. So in general, this is the kind of thing where you do need some developers and ML engineers who kind of know how to pick the trade-offs and at least know where to start and which models make sense for their use case. And then on top of those developers and ML engineers, you need some degree of fine-tuning compute. This is where you need some infrastructure like GPUs, which are hard to come by these days, in order to take that pre-trained model that's just a starting point of doing what you need to do, and then fine-tuning it on your data. And then you basically will need some annotators to be able to essentially give it, fine tune on, like essentially either producing some correct sample answers to train on, or rating the quality to do things like RLHF and these other fancy terms. But in general, you need some degree of people in the loop that are annotating the inputs to kind of help the models fine tune on what the right outputs should be for a use case. And you need domain-specific data to be fine-tuning on, such as your knowledge-based articles or kind of traffic and some in a certain project. If you're, for example, building this for your own customers facing products. And a couple other pieces of technology, you may end up needing something called a vector store, which we'll talk about in a little bit, and some ML techniques such as fine-tuning, retrieval augmentation using a vector store, and grounding. And for annotation, by the way, there are ways you can start with, for example, outsourcing or kind of like the crowdsourced platforms like Amazon Mechanical Turk or Scale.ai. But as you'll see in tier 3 and 4, with added scrutiny, we had to bring this home in order to really have trusted annotators that are not just kind of semi-random people that you don't know, with all the layers in between of the different companies and so on. So fine-tuning to actually do this requires multiple steps. First, you have to select a pre-trained model and then host it on some hosting infrastructure. And then once you have that model, they can do some things, but not really like your task that well. You identify the target task. What do you want it to do above and beyond what it did before? Then collect and label relevant data. This involves a data pipeline and the annotators to actually label it with what you want the model to output. Give it examples of given this input, this is the right output. Given this input, this is the right output. You collect a big data set of those inputs and correct outputs. Then you train that pre-trained model. This is fine-tuning it to do really well on that input-output task you described on some training infrastructure that you need. Then you want to evaluate and iterate for optimal performance. For example, having a split of some training sets that you are using to optimize the model, and then some evaluation sets that it didn't see during training that you can then evaluate, hey, how well does it do on new things that it was not shown at training time? And then you can iterate on it for optimal performance. So here's how it looks for a law firm use case, where let's say you start with a pre-trained model like MPNet, and then your target task is legal question answering at a law firm. To maybe start building up this Copilot, you need to collect and label relevant data, such as some legal cases at the firm, legal briefings at the firm, historical org-specific question Q&A. Then once you've collected them and labeled them, train the model on these on the desired outputs you want, and evaluate and iterate on it. So for example, putting in some unseen examples like the question, can you provide an analysis of the application of the business judgment rule? And the right answer, or rather, you see what the model's answer is, and you have maybe this is where annotators come back and say, and can rate the quality of it in order to help make decisions and iterate on it from there. Now, fine-tuning does typically outperform just tinkering with the prompt. This is from a paper called The Power of Scale for Parameter-Efficient Prompt Tuning, which basically found that this bottom line is humans basically, or people at a company, tinkering with the prompt, trying to tier 1 style, change up the wording to make it do what you want. But if you have an automated optimization process that either optimizes a embedding type of prompt, which is that kind of dark purple line, or kind of more straightforwardly, trains the model itself, fine-tuning the model to do very well at the task. This typically does a lot better. Superglue, by the way, in the bottom on the left is a general language, language modeling, benchmark for essential, generally how good is it at a bunch of these tasks that one cares about in natural language processing. And you can see at a given model size, typically fine-tuning outperforms just tinkering with the prompt. And fine-tuned models can sometimes contest much larger models at lower cost. So some examples, I don't know if people have seen in the news, Stanford's Alpaca, Databricks' Dolly, Koala, Vicuña, Baize. There's this whole proliferation of models, a lot of these based off of Llama and some based off of others, that are effectively, they start with a pre-trained model and fine-tune it really straightforward in a kind of neat way to kind of approximate the performance of much larger models in ways that human writers say is pretty comparable in the domains on which they are fine-tuned. And now that said, if your whole strategy is, we're just going to train this on our data and then serve it, and that's it. The problem is you have a risk of missing recent data. And here's GPT-4 explaining it, of what was your knowledge cutoff date and why does that matter? A knowledge cutoff date is the point at which the data ends. Because if your training doesn't include, as it explains, this matters because training does not include any information, events, or developments that have occurred since then, since the data set was created. So as a result, the language model may not provide accurate or up-to-date information on topics beyond that date, which should be considered when using responses for decision-making, a tier 3 or 4 problem, or assessing accuracy. So how do we deal with that? Well, Retrieval augmentation is an emerging technique that we've been using for quite a while that boosts factuality. And the idea is you take the documents, the living documents, like the current state of it, and you then use a model to embed them, to basically represent them in space in a way that lets you put them in some sort of optimized storage called a vector store, and then essentially provide these copilots at runtime, like specifically the relevant documents needed to perform their task that only the given user using it has access to. So first of all, so there's a lot of neat things here to unpack. First of all, what is this vector store we're putting them in? Well, vector store is this specialized data storage structure that's basically designed for holding and manipulating vector data. In other words, saying, hey, instead of just storing the documents, let's store them in such a way where, for example, how to set up VPN is put really close to advanced VPN troubleshooting and a little further away from just general laptop troubleshooting and very far away from like HR related documents. What you can imagine is if you could do this, if you have a really good embedding pipeline to basically put related documents and resources close to each other, then you can basically have a good search system to bring these in. And this retrieval augmentation helps with what's called grounding. And essentially having it less likely to hallucinate because you're literally providing it in the input the information that it needs to answer the question with up-to-date information. Things like grounding in your documents, which is retrieval augmentation. Grounding in workflows, which like the actual APIs and things that it can be calling if you're having code do that. Things like user data. This is a way of actually personalizing on users' data without having the model ever trained on it. It's just, brought at runtime, the model has provided it after it's been trained. So the model's not being updated at all. It's not learning any user data, but it's able to use it as information in a not learning from way to customize things for the user. Also grounding in the entities and the things you have in the organization and specific query patterns. And so this is a good thing to be thinking about when you're thinking about your ESG footprint of how you want to be grounding these things. So as I mentioned, grounding is basically given some user query or utterance and some context, which is the following best answer, is like injecting the context into the prompt so that it can better answer the question. Or in other systems that aren't using prompts so much, there's other ways of kind of sophisticatedly providing it, but that's the idea. Providing the Copilot the necessary information that the given user has access to in order to do better. So Tier 2 Copilot summary is a customized LLM implementation with some fine-tuned model and grounding the large language model with organizational and domain-specific data. Some strengths is you get improved domain-specific performance. You also lower the security and privacy risks versus just sending them off to large language models as a service. And you get potential cost savings over API usage because you're hosting the model. But there's also a lowered chance of hallucinations. But there are still very big limitations of this. First of all, it's pretty limited to single-step use cases rather than more sophisticated ones. There's limited actionability for each use case. You're still just getting text out. What do you do with that? And there's limited performance and control with a single fine-tuned large language model. Which brings us to Tier 3 Copilot, Advanced Large Language Model Pipelines. So a Tier 3 Copilot uses a stack of large language models across departments to resolve issues or perform the things you want it to do in a much more sophisticated way. Things like, medical literature analysis, like an advanced pipeline that first extracts insights from medical publications, then identifies relevant research findings, generates summaries tailored to specific audiences, using vector stores for efficient and context-aware information, or these use cases in the enterprise of account team follow-ups, multilingual IT and HR support, medical literature analysis, as I mentioned, and automated content moderation. So what does it take to do these more sophisticated things? Like, if you sit back and think, there's a lot that goes into multilingual IT and HR support as a running example. What do you need to get started? As before, you need pre-trained models, but you'll probably need a whole stack of them, of several pre-trained models fine-tuned on your specific use case, not just one. And the more of these you have, the more it takes to maintain, and the more dedicated AI and ML teams you'll need to essentially maintain those. As well as you'll need connectors to basically perform single system actions, to actually have, essentially it's like the actuators, like having the Copilot not just process text, but be able to help perform the actions and not just say, hey, go do this. These kinds of the investments required to basically have a multi-LLM stack that can actually do things or take actions in systems in a secure way involves more fine-tuning, compute, and ingestion infrastructure, because more models, more annotators, because more tasks, more dedicated AI and ML, and more data, one per model, as well as system integrations to be able to have the copilots perform the needed actions to get information as needed into the prompt or take actions on behalf of the user. So let's dive into a use case, creating follow-up emails for your account team after a call. Tier 3 Copilot use cases have multiple steps. So, for example, stacking models to do these gives you more control. So, for example, with actually, let's walk back one step without going to the models yet. So, for example, to create better follow-ups for your account team, first we need to transcribe the call into text, do some entity extraction linking to figure out, oh, this thing they're talking about, this person, who is this? Then maybe some sentiment analysis to know, hey, is a sales prospect, or this person the account team is talking to, kind of how's it going? Figure out what the action items are, sending emails, and as part of the middle step, also summarizing what's going on. Stacking models gives you more control to have individual team members, for example, or people at your company improving all the different steps and make sure the whole thing is at the level of performance you need. For example, using different models like Whisper from OpenAI to transcribe the call, which is open source, so you can kind of run it locally, which is great. Entity extraction and linking using an entity database plus a model to detect what, like contextually, whether, for example, the word office is referring to Microsoft Office or like a physical office. That's an ML problem right there. Sentiment analysis with models, summarization with a model, and then some system integrations to actually do the things that you've extracted, such as a Microsoft Teams automation and Microsoft Outlook automation if you're using Microsoft. Now, to do this, if you look at all the things on the left here, this is a bunch of different models, and model selection at this stage becomes pretty critical. For example, you have to think about modality. Like, is this text, what's the input, what's the output? Is it like text in, image out, text in, video out, image to text? Thinking about the size you want to have, like smaller models run faster and can be trained faster, but may not be as powerful. But you need a lot of data to do well with the big ones. Scope, like do you want to have, how do you want to split it up? Do you want each model to do a different task? Do you want one model to do a bunch of tasks? On the fly learning, do you want to, do you want it to, how many examples, do you want to have it do for new things? Do you train on open data, domain specific data, some combination? Do you train it to generally follow instructions? And so on. There's all of these considerations for each and every one of the models that you pick at each of these stages. And the whole thing can kind of not work if you make a decision that really doesn't make sense for what you need. I might get hamstrung by one particular model just taking too long to run, everything times out. So this is, again, where the dedicated AI and ML expertise really comes into play to make sure that the investment pays off and it actually works. So this is where you generally need a partner that understands how to unlock the full potential of these language models in your enterprise. So with a partner like Moveworks, LLMs can deliver these factually correct, verifiable information, controlled outputs, real-time knowledge of your systems, and full context of your users and tech stack. In terms of, for example, in partnering with making it a tier 3 Copilot. So tier 3 Copilot summary, again, multiple LLMs chained together, optimized for a multi-step use case. We get new strengths like high control and performance, more actions into existing systems, though there's still some limitations. It may not scale for enterprise-wide business problems. because all of the problems that you have across enterprise may have many more things, many more integrations, many more models needed to handle the whole scope. And many tier 3 copilots create cognitive overload for users. And that's pretty important to take care of. Which finally brings us to tier 4 copilot, enterprise-wide LLM adoption. Tier 4 copilots solve enterprise-wide problems. For example, in the top right, company-wide AI-driven support. It's an end-to-end LLM solution that handles employee inquiries across multiple channels, multiple languages, multiple departments, providing a seamless and personalized support with, for example, the ability to provide actions such as autonomous resolution of issues, escalating issues to the right people if not, and routing inquiries to the right resources and departments. Or coming down a little below that, the decision-making for an AI-assisted decision-making platform. If you want a custom AI solution that integrates LLMs into various business functions, for example, finance, sales, and HR, to provide insights, predictions, and recommendations for data-driven decision-making, or things to automate tasks or actions based on these insights. So for tier 4, what do you need to get started? A lot more. This is where you need true enterprise services like identity and permission services, security and compliance infrastructure, analytics infrastructure, native integrations, and all of the ML techniques said before and more in terms of how do you actually get these language models to properly reason over text, which is something that's domain dependent. Models often we've seen is that both there's literature about this and in internal experiments, models not trained on a given body of knowledge are not as good out of the box at reasoning about it. So you still need some degree of this training on like domain specific data, and not something you get super well out of the box for more sophisticated things. And you need large investments. You need a lot of fine-tuning compute and ingestion infrastructure, many more of these GPUs that are hard to come by, and good infrastructure for it. You need dedicated money more on the dedicated AI and ML teams front, more domain-specific data, and this is where security really comes into play. You need a security team on it for having it be seamless for users. It takes UI and UX. It takes many annotators, many system integrations, data science team, and so to manage this scope of problem, we've seen like really this is where having a whole company dedicated to it really pays off in delivering state-of-the-art performance. And if you have many use cases, many teams, and many systems, this is where, again, the scope gets pretty large. Like all of these queries coming in, like, you have to handle like, how much will I be based on my RSU grants versus how I got locked back from vacation and locked out of my Okta account, where you need to be managing, okay, some of these are going to IT service, some are HR, finance, facilities, and then some of these need to go to IDAM, ITSM, others HRIS, some of these pulling in wikis, internet. It becomes this whole complex orchestration that is much more sophisticated. And reasoning is critical to choosing the best option. And this is where it's helpful to have models that are really designed just for decision making on top of all the others, such as considering all the context. How do I get on, for example, how do I get access to NetSuite? Considering the context about, for example, like this seems to be like, you predict what the domain is, like what is the role of the user, what's the business context, displaying the article, kind of pulling up self-service forms if needed, and picking of all of the different available options of like, oh, well, there isn't auto provisioning for this, but there is an article about it and there's a form. What solutions do you provide? What is the best option of all the things available across the enterprise? Involves considering all the context, understanding realistic options, and ranking them according to all the information available. And why this is hard is you have to manage these models as you add use cases. They need to be able to scale and dynamically handle when there's new options added and new ways of understanding it that's added as well. And for this, the integration system is crucial for this expanded scope. Adding use cases and use case scope leads to an exponential growth in the system complexity, and you need this suite to scale quickly. So for example, can I add Steve to the Salesforce admin DL? It might involve Okta and Salesforce, but scheduling a meeting with Zach Hoffman may involve 2 other systems. And how much will I be taxed in RSU grants? It might involve Carta. And these integrations need to be updated and maintained as the software is updated, users are added, etc. You need to be able to have your integration suite scale quickly and take this problem seriously as well. whether it's on systems like Okta, Salesforce, Calendly, Azure AD, and more. You really need to be on top of this to have a really good tier 4 level Copilot solving a tier 4 level problem. And at this point, you might also probably will need proactive analytics to help you improve the system. For example, if something isn't working, you need to be able to decide what use cases you need to add, what resources to build. You need to know this quickly because employees expect full functional product without downtime. So for example, things like how many successful resolutions are occurring? What actions is a Copilot taking? What are the gaps in the use cases? How many users are engaged? And why this is hard is as you add user journeys, the number of journeys that users take explodes exponentially. And the data to manage increases too. And there's different types of this data. There's structured, unstructured, and with the unstructured data to use large language models to take out, you essentially often end up needing a tier 2 or 3 Copilot within the tier 3 Copilot to fully leverage these analytics kind of internally to take insights on the unstructured things. Now, our approach to enterprise analytics is involved in employee experience insights, the product you may have seen and hopefully come to know and love, being able to really give this deep view into all of the kind of things coming into the system or things coming into a different system, just like in general, what tickets are coming to the IT department, and be able to use all of this tier 4 level co-piloting to really break it down and provide actual insights. This is kind of that decision-making application, and kind of right there in the original chart of different applications. And in general, you also need security to manage multiple teams' data needs. For example, for a tier 4 security posture, you need good industry certifications, hardened infrastructure, access control, data protection, and identity input validation. Because as you move into different departments like legal and security, you need to have better division between departments' proprietary data. Teams must be more sensitive about data, permissions, access control, and you need a multitude of structures in place to kind of handle this and maintain it. And also make sure that the right queries are routed to the right departments, which again requires really solid ML and domain classification. So in general, for tier 4 copilots, it's an LLM system with enterprise features like a reasoning engine, analytics, security and privacy, out-of-the-box connectors, and more. Strength of this, you get end-to-end control, strong security and compliance, and coverage across a variety of use cases. And that's what Moveworks is. And that's what Moveworks will continue to be and is continuing to build even more sophisticated, taking it to, tier 5 once, if you think about what that can go beyond that. Moveworks is the enterprise Copilot platform. Because for a tier 4 Copilot like Moveworks, the holy grail is to allow for extensibility, to let users extend the Copilot into new domains and new use cases in a way that still preserves data controls, security, privacy, and more. And this is what our product announcement before about Creator Studio is all about. And it gives the Moveworks Copilot some awesome superpowers. Things like, for example, agent assisting with IT automation, HR, enterprise search, employee comms to be able to send custom messages, Creator Studio to generate custom use cases, on top of all of the identity permissions, orchestration, ingestion, integrations, and more, leveraging security, the Moveworks LLM catalog, and conversations and language analytics. So, coming back to the original question of how to think about your Copilot strategy. Take a look at your use case. Think about the problem you want to solve and pick which kind of tier of Copilot you need for your Copilot strategy. Is it a simpler one where you just need a basic LLM integration, like copywriting and sentiment analysis? Do you need a customized LLM implementation for example, domain-specific things like answering questions in finance or summarizing legal documents? Or do you have a more sophisticated thing like setting up follow-ups after a sales call, multilingual IT and HR support, where you need some advanced LLM pipelines combining multiple, or something like enterprise-wide support, decision-making, compliance and security monitoring that requires tier 4 level enterprise-wide LLM adoption? So there you have it, 4 distinct tiers of copilots that you can design using large language models. And you have a choice to build something like this yourself or partner with the vendor that specializes in this domain, which gives you much faster time to value. And that's it. I think we have about 5 minutes for questions. So yeah, thank you so much. And I will stay open for questions.
Awesome. Thanks so much, Matt. At this time, I'd like to just remind folks, if you'd like to ask any questions, just go ahead and ask in the bottom of the screen. There's a Q&A module that you can use to just directly get into this, and then I can help ask questions. If you also would like to ask a question live, if it's a more complicated question you don't want to type, feel free to raise your hand as well, and we can go ahead and get right in there. Cool. I also put up a quick feedback survey in case anyone wants to let us know if there's anything else you want to hear about in the future, and we will definitely add that to our lineup for future webinars. As far as engaging with our Copilot, so if you are, if you're not currently a customer of Moveworks, then go ahead and talk to your account representative. We can help get you set up with more conversations there. If you are already a customer of Moveworks, then to a degree you already have our Copilot capabilities as part of just your regular interaction with Moveworks, but also we do have additional updates that are being rolled out over the next couple of months. So you'll hear a lot more about those in our upcoming webinars and events. So definitely keep your eyes peeled for that. We have a question from, also from Trisha. Any chance I can get links to replays for other webinars on this topic? So we are posting a series of these webinars over into Moveworks Academy for existing customers, but for folks like Trisha, if you're not already a customer, then we will also be posting this three-part series to Vimeo and YouTube. So we'll follow up with all the folks that have registered for these events with links to all three of the webinars so you can watch all of them. Additionally, we have a question, Matt, for you from Swati. In your experience, how many enterprises have started with tier 1 scenarios or further along tier 2, tier 3, et cetera?
Very much a power law. And part of it has to do with the level of investment required. So there's a lot of people trying tier 1 solutions because it's just low cost, might as well give it a shot. But as the level of investment increases, we definitely have seen a exponential drop off, and many fewer have tier 2, even fewer have tier 3, very few have tier 4. Tier 4 is basically a company has been built on this for many years that has really had a solid vision and security postures and all of these and integrations built out from the very beginning. And so this is where we're seeing, if there's this flood of vendors, new vendors out there that just are oh man, GPT-4 is really cool. Let's build something around that. And they're basically selling at a pretty high price, a wrapper, a tier 1 Copilot effectively, or maybe piecemeal tier 3, taking some, or tier 2, pulling in some retrieval augmentation. But really they don't have the security, they don't have the, the analytics, they don't have the UX. There are a lot of brand new, it takes a long time and a lot of investment to build to tier 4. And so this is also where you have to think about the build versus buy. It makes sense to build tier 1. It makes sense to possibly build tier 2. And you start getting to tier 3, tier 4, that's where you really got to think about it. And where there are fewer vendors out there that actually have that. And we're actually building out in-house for and in general, this is something where for your product, for the thing that you are providing to your customers, it is a great idea to invest in, all of the new technologies that are available to try to really have tier 4 level AI product to serve your customers. And then there's a question of for internally serving your use cases and speeding up your delivery of that. It's very helpful to have a partner that also understands these things and has built it already to kind of partner with and provide that enterprise level, tier 4 level experience and security and everything as you're kind of building that type of thing out for your own customers.
Awesome. We have 2 more questions left here. I know we're at time, so just another minute or 2. Had a question from Abhinav over at Cognizant. Just curious, how are we measuring success of generative AI implementations? I know this is kind of a new field, so. Just
Oh
curious.
yeah. So in general, I mean, in the field in general, there's two types. There's offline metrics and online metrics. Basic idea is offline, you basically have like a ground truth set where you say, okay, given these inputs to a given part of the system, like sentiment analysis, here is a call transcript. Here is what the sentiment of the sales prospect was. And then you have a bunch of those and you like evaluate how good is this like part of the LLM pipeline at that. And you only deploy an update to that if it does better on your test set of examples. And so that's what we've been doing at Moveworks for, a long time, having very good offline evaluation, as well as the online side, which is you take the whole system. What is the actual business metric you care about? What do you want the whole thing to do? How do you measure its success? And Moveworks for, that is a largely resolution. Like what percentage of the issues that are coming into IT service desk, coming into HR, able to be handled autonomously by the Enterprise Copilot so that the department can focus on more strategic initiatives, building things out, and the kind of more complex issues, and not just going around like approving account unlocks, answering the same HR questions over and over. So yeah, it depends on the Copilot and the use case. And for Moveworks, it has been resolution and acceleration. How much can we speed up mean time to resolution, bring it down from days to minutes, or in some harder cases, hours? And how much can we actually end-to-end resolve ourselves to take it off of people's plate?
Awesome. Thanks so much. And then we also have a question from Juicy. I want to make sure I'm pronouncing that right. So on the question that you asked about what's the typical timeline for a tier 4 implementation in a company that has about 1,000 employees in a highly regulated environment such as medicine, I can take that in the sense that, having worked with implementations of our Copilot before, really the answer is it depends. I could imagine that this is something that would take probably on the order of multiple months to be able to do properly. And I think a lot of that has to do with regulating or rather navigating all the regulatory environment and kind of making sure that all the stakeholders are comfortable with the implications of using generative AI in this context. So it does really depend. I would say, if you're interested in deploying Moveworks at your organization, it really will be something that the account teams can help you out with by just having a better understanding of your tech stack, as well as what it's actually needed to get this rolled out.
Yep. Yeah, and in terms of implementing in the sense of like building it oneself, that's definitely not a matter of a couple months. That is a much, much larger, multi-year investment with like many, many people. But implementing with a vendor like Moveworks, right, is on that timeline.
Awesome. So one last question. Sorry, I know I said two, but one last question from Swati. Annotators are an interesting addition to teams. Do you see them more on the engineering space, like, sitting more with the engineering folks, or do you see them sitting in the business side?
That's a great question. So if you have Moveworks, like I work with annotation managers all the time, who then working with with the annotators themselves to basically like, oh, this is really interesting because it is something where there's benefits of working with both types of both types of folks. Because on the one hand, like knowing exactly like how like what the annotation guidelines are, like how to like actually handle the edge cases is one of the main things annotators are doing is not just like writing the same things over and over again, but dealing with the hard use cases. Like, if it's an underspecified query or just something that's, that's really kind of falls between the boundaries or guidelines, there's this decision making of how do you update the guidelines of what the right answer should be, which is essentially engineering too. Like deciding, like large language models are largely trying to fit a decision boundary of how to handle, well, I guess this is more like the classification side of things, but like many use cases involve, here's some inputs, what should you do with each one? What are the boundaries of these inputs should be handled this way and these should be handled that way? And on the like kind of in the gray area between, there's a lot of careful thinking to decide what should be handled each way. And that's where there could be product. It's helpful to have both product input on like what makes the most sense for the product and engineering input on what's the like most straightforward to learn, because you don't want to overfit some really complicated boundary that leads it to like get easier examples wrong.
Awesome. Thanks so much, Matt. And thanks, folks, for staying a bit longer here. So what I'll do to kind of conclude this is also mention that, this is the end of our three-part AI 101 series, but we do have a lot of additional content if you're interested. Scott and I were having a bit of a sidebar in the chat here. I posted a link in the chat that links to all of our other, content about AI. On our publicly available YouTube channel. So just go ahead and take a look at that if you'd like. If you enjoy hearing from Matt, our unofficial Bill Nye of AI, then you can see a lot of his other content there, as well as from our other folks at Moveworks. So really, again, want to thank everyone for joining us for today. I hope you really enjoyed this content. If you'd like to hear more about this or anything else that's going on within this space, then go ahead, leave us some feedback, shoot us an email if you have any suggestions, and we'd love to put on some more content for you. Again, thanks again. I hope you found this valuable and hope you have a fantastic rest of your day. Take care, everyone.
Thank you.